All right, guys, welcome back to the channel. This is part two of building out this battery pack, the LEV60F battery that you can get from batteryhookup.com. And 100 amp BMS we've got connected here. And we've got this cool case that we'll talk about in a second. But what we want to accomplish in this video is finalizing the battery pack, where we got the fiber sleeves in here to give it protecting in case, so the casing doesn't accidentally short in case there's movement and this protective um, shrink wrap gets messed up, and then we want to prevent that from shorting. And so the idea is to go ahead and finalize that. It's going to be kind of a compression framework with some extensions with all thread, because I want to put it in this box temporarily but securely, because I have plans to upgrade this in the future. But this box, let's talk about it for a second. I found this on Amazon, and I really like this box. That it almost looks like a battery already. It's a toolbox, but it would look like something you might find on one of the manufacturer sites that kind of build professional battery packs. All the packs I've done in the past were kind of like, they look very do-it-yourself, which is fine. This just is going to be a little more polished, and it's got some things on it that I want to take advantage of, and we're probably going to do a video series in the future on with these accessory rails and so forth. But for this project, we're just going to finalize the battery. We're going to figure out how to get it in here securely. And then we're going to figure out where to put these terminal blocks. First thought was on top, but if we do that, then these no longer can stack, which is one of the designs of the manufacturer put in these. These are very stackable with themselves and other systems that they have in their lineup. So my idea is just to find a way to put it right here and here, so that in case you build a second one, you'll be able to parallel them or series quite easily through these high current lugs here. So let's work on that. Like I said, we're going to start on the battery pack, and then we'll go into the box. All right, let's knock out a fairly simple task here of just installing the lugs terminal posts. So what I did is I took some masking tape here. I used the corner of this metal plate here in this corner to give me a nice straight line across. And I looked on the inside, and I'll show you once it's mounted. There's just hollow space back here, so it should be perfect to have the other side poke through. So what I did is I took my um, caliper here and set it at 1 inch. So I'm just going to do 1 inch across from this crease. I put my thumbnail in here and gave me a crease, so it gives me a nice line to work off of. So we'll go from here, and then we're just going to go 1 inch down. So that way I can repeat this on each one of the boxes that I might build in the future. Now we have two places that should be very, very close and repeatable. So I'm going to go ahead and install those now. All right, guys, one of the reasons we do these kind of videos is so that you can learn from my mistakes. So my measurement was a little off. I should have probably gone to 1.5, maybe 1 3/4 depth, because I ran into this mesh here, supportive mesh. I spent the last, I don't know, 10 minutes just trying to clear that out so I could put the bolt down. Not a big deal, just save you some time if you're doing what I'm doing. All right, we've got the terminals installed here, and my logic is red on the right, RR. So that's how we're going to go. Next, let's work on getting the pack built, and I'll show you how I'm going to get that secured on the inside. All right, we got the pack disassembled, and we're going to show you here how I'm going to put things together. We've got our fiber sheet, which I'm probably going to double up just to give it a little bit more protection. And we use some poly cutting board for our ends that we will use to compress them with. I've cut some angle, not iron, but aluminum. And so the idea being is that we'll be able to push these together and then use 1/4 20 threaded rod to create our compression and also our framework, because these are cut almost exactly the same width as the box. So they should not move around this way. This way, I'll demonstrate how I'm going to lock that in place, but it's not going to rattle around that much from this direction. So I'm going to keep building that, and I'll show you where we're at in a few minutes. All right, we've got it somewhat put together. The idea being here is we've got our poly on the outside, we've got our fiber sheets on the inside, trying to create a nice barrier between this casing so there's no shorting. To give us a little bit of cushion. We don't want direct compression right onto the cells. So these boards will help kind of dissipate, distribute that force. And so we're going to have 3 of these. We're going to have one at the bottom, And the reason why this one is on the corner is because I want these down posts that I'll show you later. And then we'll have one in the middle and have one at the top. And I'm not going to do that because that's just too dangerous. So these are probably just going to go like this. And so that we'll have 3 rods across each side, giving us compression, hopefully uniformly. And so I'm just going to keep working on it. Next thing is to find the holes and go ahead and put a threaded rod through there and start showing how I'm going to tighten everything up. And we're getting closer and closer. All right, we've kind of finalized our framing here. And like I said before, we just used 90-degree angle aluminum and just drilled holes on the sides and used 1/4" 20 thread rod to give us our compression. But if you notice, these top bars are a bit longer than these. These are just cut short because they don't need to be any longer, but these need to be a little bit longer because what we're going to do is we're going to put a sleeve of another aluminum tube over these and then use these nuts to press them out to secure into the box. So I'm going to go ahead and do some test fit ups and then I'll show you how that works once I know that it's going to work, and we'll come back to that shortly. After doing some dry test fitting, I noticed that there's these protrusions that are used for the divider system that this toolbox had. They kind of are in my way and would definitely free up some space. So I'm going to use a oscillating saw, trim this probably bar here, this here on both sides, and maybe this on this, just to make as much space as possible. I was hoping I wouldn't have to make too many alterations on the inside, but this isn't too big of a deal of just trimming away some of this to make some more space. So I'm going to work on that, and then we're going to do a battery fit up. All right, we've got the pack in here, and I've extended these bolts here, or these nuts, to press these collars into the material and made it pretty snug. Now, depending on how accurately you cut these, you could probably create a friction fit. You not need that, but it works well. And I've even turned this upside down, shook it a little bit. It's not going anywhere. The reason I like these cells for this particular use case is they're shallow. I only get 70 amp hour out of these. And I want to do one that's bigger, and that's an upcoming video. But I like that the toolbox can still stay in there. And you can put some accessories in here, and we'll go over that in another video. But I do like that. So now I've got to figure out how to get the BMS wired in, get them wired into the terminals here, and make this a product. So let's move forward. All right, before I finalize how the battery is on the inside, I need to do some external stuff. As I may have mentioned before, I want to install XT60 connectors on each one of these corners. And so I started to take it apart and look at it. And there's a good bit of bracing here and the injection molding to give it rigidity. And so what I'm going to use is this bottom 2 mounting holes as my location indicators, but I need to remove all of this support right here so I can drill a hole straight back into the cavity, and that's where the wires are run at. And then we're going to install these female connectors. It's going to basically go right there. And in order to help me make it perfect aligned for each one of these, because I'm slightly OCD on stuff like this, created a 3D printed template that I'll be able to line up here, use some tape, draw my opening, use a drill and some files and make the opening, tap some holes for the screws. So I'm going to start working on that, and we'll revisit once we get those completed. All right, guys, we've made some progress here. I went ahead and notched out behind here the wall, but if you notice, this is now yellow. As I was trying to work on this steel, it's really hard to get a precision square notch in there. I'm still working on it, and I may continue to go down that path, but I thought, I do have a 3D printer, and so I went ahead and modeled this in Fusion 360. I went ahead and put my notch in. Now, obviously, this is not nearly the strength of steel, and I am printing in some other filaments to try to get the most rigid thing I can get, but I have tested the attachments on here, and they seem to hold up. So to get the project moving forward as I continue to work on the steel, I went ahead and 3D print these. I'm going to go ahead and print 4 of them, but I already was able to model in the XT60 connection. And so I'm just going to keep moving forward. I may, replace these and get the steel ones done. I'd love to find a local laser service where I could just get that notched out in like, 15 seconds or something. But I don't know if those services exist where I'm at. But I'm going to keep moving forward and show you where we're going. And I do like the 3D print because I can add some color to it. I can, my first one was in black to try to, it matches very well. But I kind of like, let's do some pop. The other thing I can also do is, I don't know if I'll do it yet, but I could put in lettering for like the specs of the battery. Put them on the sides here, put them on this part. Either way, they turned out really well. These aren't like absolutely perfect, but I don't think you'd really notice unless you really get in there and try to feel for these edges and stuff. But I like what it looks like so far, so I'm gonna keep moving forward to it. So the next thing is I'm gonna go do all 4 of these, get the wires attached to the XT60 connectors, and then start wiring on the inside, and we'll keep moving forward. All right, we've got our plates installed here. These are ASA printed filament for 3D printer. They're durable in the sunlight, UV, and heat. So these should, even if you leave them out in the sun all day, they should not melt like PLA might or deform. They seem pretty solid. Only time will tell if they actually hold up to the abuse of outdoor use and the adding and removing of these tool holders and stuff. So far, it works really well. I'm not seeing major deformities or any real roughing. But again, this is just a couple times versus the hundreds or thousands you might use on the job site. So we've got our XT60 connectors here all wired in. And so the last step is to get the battery in, the BMS installed, and kind of wrap it up. And so I'm going to work on that. We'll hopefully finish this out. All right, guys, before I finish buttoning this up, I just wanted to show you one more time. We've got our bus bars back on there. We've got the pack cinched in so it won't move around even if you turn it upside down. So now I'm going to put a poly board on top of this and mount the BMS and the bus bars to get to the XT60 connectors. So let me work on that. We're getting really close. All right, last view of the inside there. We've got our BMS wired up. We've got our terminal lugs wired in. We've got our bus bars going to the XT60 connectors. The last thing for me to do is mount the power button and call it a project. We were able to keep enough space so that the toolbox still sits in there, so we can store accessories or some wiring and stuff in there. So we're getting really close. Let me button it all up and then we'll do beauty shots. All right, guys, we finally got this wrapped up. Let's go over some of the things we've done. We replaced these metal corner pieces with ASA 3D printed brackets here. We'll see how those hold up over time. In the worst case, I still kept them and I can still create the socket. It's just a lot of file work and was kind of tough. I think this actually is pretty cool. It gives me a chance to customize the color a little bit. Our XT60 connectors, you can use these for supplying voltage to whatever, but also use for charging. But also we have on the back big terminal lugs so I can handle the higher amperage. I think I've got this BMS set at 100 amps. We've got our power button right there. And there we go. So in upcoming videos, we're going to be looking at creating our own extra accessories here. You can buy little tool holders like from Lowe's or Amazon. I'll link in the description. And then I've been buying them to get the metal brackets on them. Let me show you one real quick. Here's one I've been working on. It's a prototype, but I would take the metal piece off and then just on my 3D print, I would just, reconnect it. That gives me my little connections. So we're going to be working on a few different things with this. And so look for that in an upcoming video. The next build I'm going to build with this particular toolbox, we're going to try to jump up to 200 amps. But this one uses those LEF60F cells from batteryhookup.com. If you'd like to get one of those, I'll put the link in the description. If you use my discount code TECH, you'll get some costs knocked off. And, until next time, enjoy and see you guys later.